So we'll go ahead and get started. Thank you for joining us here for the August, almost said April, August meeting for North Texas Microwave. I am showing the initial slide, and there is a rainscatter.com image to the right that I hope sometime we can talk about before we're into the winter. Um, so, so we've begun the meeting, and we're going to have a technical program that consists of Al going over sun noise measurement procedures and the relevance thereof and the how to. And then from the Lincoln, Nebraska conference presentation, he's going to talk about another subject that has a title, Another One-Way QSO Attempt, What's Wrong? And then we're going to review the contest plans that are coming up for the part one or first weekend of the ARRL 10 gigahertz and up contest. That's next weekend. And at this point, there's not much time left to do anything other than pack your bags if you're a rover, because it's time to be ready. Then I'm going to represent the talk given at Lincoln a couple of weeks ago on RF0 as a beacon driver, but I have probably 10 or 15 new slides that are on the end of that presentation, as there's been more learning and continued activity as we build the beacons for 10, 24, and 47 with Q65 capability. Then we'll have a show and tell by members and other items in business meeting. So at this point, I'd like to turn it over to Al and the sun noise measurement. So I will get that teed up.
Hey, Jim, you're kind of breaking up here. I don't know if that's me on the receiver or what. How do you copy me?
100%.
Yeah,
Anybody else have a problem hearing me?
Sounds good to me.
Sounds good to me.
Good here.
All right, well, wish me luck in getting out then. Kind of embarrassing with the internet situation over here. I'd like to talk about the another one-way QSO attempt first, Jim.
Oh, sorry. How many times do you have to tell me that?
I don't know.
I think it's this one.
Probably says Central States in it.
Displayed now. Not sharing it, sorry. Okay.
Right,
ready when you are, Al.
Alrighty. This is the presentation I made at the Central States VHF Society a couple of weeks ago, along with Jim. And what prompted this was, on the microwave bands, we're not alone out there anymore. And a lot of times these QSO attempts result in one-ways. And when you're on the microwave bands with similar setups, similar power, similar noise figure, and only one person is hearing one end of it, you start to ask yourself, well, what's wrong? And that's what we're going to talk about here. So go ahead to the next slide, Jim. So, most of the time it's, well, back in the old days, it's, can you hear me type of thing. And nowadays it's a lot of, can you see me type of thing, which is nice in that you do get DB reports. So it's nice to compare DB reports, from WSJT. But when you can't hear or see a guy, you first ask yourself, are you on the moon? And on the upper bands, you can get a little bit of moon noise. So that kind of helps to keep you on the moon. But then the question would be, okay, the moon's rising to the east. So when the sun rose earlier in the day, were you calibrated on the sun? And that's a lot of times that's what I do. I kind of hope that the sun comes up before the moon does, and you can use one to calibrate the other. Then the other thing is, well, can you hear your LNA noise increase when you power it up? Because most of the time, for an EME type of system, your LNA should be out at the feed, and you should be able to hear, the noise rising from that, and probably to the tune of 15 to 20 dB, depending on how much gain you have out there. So it's always nice to have a separate on-off switch for the LNA. You power up the transverter, then you power up the LNA. Oh yeah, I can see it. So there's a comfort level there. And I usually set the IF gain so I can get a nice S meter readings so that I can see that dB increase. I never set all my transverters down to S0 or S1 because then you don't know if they're broke or if they're working. So, we're not too worried about dynamic range around here, but the purists would say, you got to control that gain. But I take advantage of it here and use it to verify that I'm working correctly. So lastly, what is your termination of cold sky difference in dB? And when I asked that question to the Central States crowd, I was happy to see that a fair number of them had this sort of switch. And then, for those that don't, maybe they're asking what or why. So we'll talk about the advantage of having that switch and what it takes to incorporate that. Go ahead. All right. When you connect any antenna to a receiver, you're basically hearing or seeing noise that is displayed on your S meter. And if you hook up an HF antenna to an HF rig, generally you're going to see background noise, especially down on 160, 80, and 40. Maybe on 10 meters you might not because it's generally a quieter band, but you will see some noise increase. And with the usual conversion gain that we have on EME, we still don't know if that's a good noise level or a bad noise level. What we need is a reference. And the best reference is to point the antenna down to the ground, which is actually 290 Kelvin. And then you point back to the cold sky. And the difference in dB provides an indication of how quiet or noisy your system is. And you always want the load to be higher than, we'll call it cold sky. And I'll show you why as we move on to a couple other graphs. But instead of pointing, well, back up, Jim. Instead of pointing the antenna down to the ground, I just switch in a 50 ohm termination for my 290 Kelvin reference. And because some of these rotors, like the new slew drives, they move so slow that to go from cold sky to ground, would take many, many minutes. So to have a switch where I can switch in 50 ohms right at the input to the LNA would be an advantage. And that would give you some confidence that your system was working or you had another problem. Go ahead, Jim. All right, in general, the background noise on the microwave bands can be as low as 25 or 50 Kelvin. And that's considerably lower than the 290 Kelvin from a load. Now on 6 meters, I think I remember, the sky noise can be like several thousand K. So it's very, very noisy. So the actual level depends on the side lobes of your antenna and what the other lobes are pointed at. And also the problem we have like on 902, 2304 is man-made interference from cell systems and from internet service providers. Bands like 10 gigahertz right now are pretty quiet. 3400 is maybe. 5760 is pretty noisy, and 2304 is getting there, and 902 is really noisy. When I say noisy, I'm talking about a lot of man-made interference. I mean, years ago when we first got on EME, we didn't have these issues, but we didn't have fast internet either. So I'm blaming it on the fast internet that most of you guys out there have, maybe not me. So let's move on to the next one, Jim. All right, so first off, when we're dealing with sky temperature, we need to be dealing in kelvins. And it's not degrees Kelvin, it's just kelvins. And you can convert the noise figure to a temperature by taking the noise figure in as a ratio, subtracting 1 times 290 Kelvin gives you 35 Kelvin. So a 1 dB, or excuse me, a half a dB noise figure converted to kelvins is 35.4. If you go to the next slide, because where I have a graph of that, and okay. So here's a graph of that. Basically, 0 dB noise figure, 0 Kelvin. 2 dB noise figure is about 170 Kelvin. And in between, you get the numbers like half a dB. That on the x-axis, you go up to the curve and over, you get that 35 Kelvin. For a 1 dB noise figure, it's about 75 Kelvin. And we need to convert dBs to Kelvin so we can add on antenna temperature to it. Go ahead, Jim. All right. Can you slide it up a little bit, or do I do that here? Cut off a little bit there. All right. So there we go. So if we install our 50 ohm load on our LNA, our equivalent system noise temperature will be the 290 Kelvin of the termination and the 35 Kelvin of the receiver for our half a dB noise figure receiver. So that equals 325 Kelvin. Now, when we attach the antenna to the input of the LNA, our equivalent noise temperature is now 50K plus 35 equals 85K. Well, the nice thing about these two numbers is you can take 10 log the ratio of 325 divided by 85 and take 10 log of it, and you get 6 dB. This is a good number to try to achieve on any microwave band, where hopefully your antenna temperature is lower, and that takes a good antenna, and it takes a quiet background, if you will. We can go, let's see. If we don't see anything like this, then we probably do have an issue that's worth looking at. Go on there, Jim. All right, here's a plot that's kind of interesting in that it shows the sensitivity versus noise figure. This is a pretty basic equation that says the sensitivity is minus 174 dBm per hertz bandwidth plus 10 log bandwidth plus 10 log noise figure. And if you had a perfect receiver in a 1 hertz bandwidth and 0 dB noise figure, we'd have a noise floor of minus 174 dBm. And if you look over here at this number, if your termination is 290 Kelvin, then this TA over T naught subtracts out, and you have just noise figure. So you have a straight line of what 0 dB noise figure is minus 174 dBm. If you go up to 5 dB noise figure, it's minus 169 dBm. This is in the system where the termination resistor is 290 Kelvin. But in the world of looking up at the sky, we get to manipulate this last term out here and look at the effect that lower antenna temperature has. So if we have a 25 Kelvin noise temperature for the antenna, a 5 dB noise figure, still provides maybe an extra dB or so of sensitivity. But as you get down closer to 0 on this blue curve, you can see that the sensitivity is improved immensely with lower noise figure, but also lower antenna temperature. You could generate another plot here of, say, TA equals 10 degrees, and you're going to be somewhere down here as well. And you can also see if your sky temperature is more than 290 Kelvin, you're up here where noise figure doesn't make a lot of difference because you're totally dominated by the antenna temperature. But in microwave situations or installations, we'd like to be in this range here where you can actually get maybe a 7 dB or even greater 50 ohm over cold sky. I'll go on there, Jim. All right, so the next two slides show a couple of ways of incorporating this cold sky determination switch. And if you go to the next one, it's basically a block diagram of a transverter system driven by a sequencer. So you'll probably get some other ideas here, hopefully, but these are what typically my system would look like in terms of the transverter hookup. You've got an IF rig. A lot of times you have a transmit and receive line going to a transverter. And then on the transmit side, we're going to send power out to the PA, and then we go to we'll call it our septum feed, which is typically used on microwave bands. And this septum feed is for generating circular polarity, which we do on all the microwave bands from 902 through 10 gig right now. Or excuse me, not 902 through 5760. 10 gig is linear as well as everything above 10 gig polarity. On receive, I have a relay in front of the LNA, and you can see that connected to the receive port. I know you can't see my cursor, but hopefully you can follow the arrows from the septum feed. Oh, thank you, Jim. It goes into a single pole double throw relay to the LNA with a 50 ohm load on one port and the antenna on the other port. And it's this relay here that we're going to control to look at, we'll call it cold sky over 50 ohms. Now, just to talk a little bit about a sequencer here. This is your typical DEMI or W6PQL sense sequencer. Normally, there's 4 outputs, and these can be configured in various ways. The normal receive state is in the number 1 position. So I'm sending 12 volts to my LNA. And then these other number 2, 3, and 4, number 2 is 24 volts on transmit. Number 3 is control line. And number 4 is a transverter control. You can do this in various ways, but basically I'd like to make sure that my relay is terminating the LNA before I go to transmit. So the main purpose of a sequencer is to help control the PA. Now I realize I was talking to, I think it was Jim earlier, and I think one of the ICOM rigs, or maybe all the ICOM rigs, have some sequencing both going to transmit and back to receive. And sequencing going back to receive is as important as going to transmit. Basically, you want to limit any power going out until your system is in the transmit state totally. And when you're working with waveguide relays, you've got maybe 100, 200, 300 milliseconds of time as it transitions from receive to transmit and from transmit back to receive. So the TR sequencer here sequences going to transmit and sequences when going back to receive, which is very important. Now the next thing is how do you control this relay out here? Well, the way it's set up right now is if I want to go to a termination, I supply 12 volts to this relay through diode D3. Normally, the control voltage comes through D2. And of course, putting a diode across the relay coil is a good way to keep you from getting jolted, and also protecting other components and circuitry. So I always put a back EMF diode across a relay coil, that is. So when I want to go to termination, I just apply 12 volts or 24 volts to D3. And this guy will go from antenna to 50 ohms. And that way you can easily get a quick check, a quick sanity check as to how your system is working. This is not a fail-safe situation. I don't use this particular method unless my relay, like I have one waveguide relay on 10 gigahertz, it normally stays in the receive mode until I go to transmit because it pulls a lot of current, and the current, it's not a it's a fail-safe type of relay. So I prefer option 2 here, and if you just flip to the next slide, this particular slide here, when the system is not fired up at all, you can see that the relay, normally closed position, is to the 50 ohm load. So when this whole system is off and when I'm not energized, the LNA is terminated. So I only go to the feed through the normally open port when I'm actually receiving. And that way, when I want to go to termination, I just remove the 12 or the 24 volts from the relay. So that's what this switch is doing right here. So it's another way to do it. It all depends on whether or not you want to have this relay connected to the LNA energized when you receive or energized when you transmit. Personal preference. I like this method better than the other one. Any questions about that? All right, let's go on, Jim. Now we need to move on to how we can make that measurement. So let's look at several methods here. This is the old-fashioned way of doing it with the GR meters. I like these. They have pretty good averaging. They work at 30 megahertz. We convert them to 28, and they have a nice big scale. And there are other ways of doing this, but these are ones that I've had around for years. And so this is what I'm kind of used to using. And you can see, especially on the meter on the right, you can see it's 10 dB full scale. And when you're down 10 dB, you're over here. So you got a nice range you have a nice scale, if you will, for looking at how many dB increase you have either in moon noise, sky noise, sun noise. Just, very universal. Go ahead, Jim. Excuse me. This is the system that I use predominantly out when we're doing portable measurements for sun and moon noise, and it converts the 144 megahertz down to 28 for the meter. And I got a little preamp up here as well for lower gain systems, because this noise figure, or this meter, has a pretty high noise figure. It's not like your weak signal receiver. I mean, the noise figure is it's got tubes in there, so it's probably at least 10 dB. So you at least need enough noise to overcome it. Otherwise, you're going to be sitting down here on the far left-hand side of the scale and not be able to make any meaningful measurements. Go ahead, Jim. This is probably my first method that I used years ago, and it works well, but it's kind of a narrow band approach, if you will. You basically take the audio out of your speaker, headphone jack, or whatever, and you put it into an AC voltmeter like this, and you get a nice dB scale up there, just like the previous measuring instruments. But in order to make this work, you have to turn the volume up on your radio to get a reading, and reduce the RF gain to get it down in the linear range. And most of the time, you should probably turn the AGC off. So start with that. Increase the audio gain, turn the AGC off, and turn the audio up, and reduce RF gain. And you can generally tell if you're getting meaningful numbers by adding an attenuator in the RF line or some sort of self-calibrating. But you have to get this meter, you have to get your whole receiver operating in the linear range. The disadvantage of the audio meter is that it does operate only over several kilohertz. So it's going to give you kind of a jumpy reading, but you can put a capacitor across the input and kind of squelch that a little bit. But I also use this on 5760 at times, because the GR meter is picking up so much broadband noise, man-made noise, mainly ISPs and such, that it's really hard to make a meaningful measurement. So, I crank up the audio meter and or look at it on my flex radio, if you will, to try to get a noise measurement over a narrow band. But it's another technique. If we go on to the next one, I'd never tried this until I was talking to K0 DSP, I don't know, a month or two ago, but it's using the echo mode on WSJT. And this is explained in detail on Bob Atkins's website. He's got a plethora of good stuff. So check out this URL, bobatkins.com/radio, and you'll see this, or you'll see his instructions on how to use WSJTX for measuring noise. And what I did was, you'll see this better on the next slide. In fact, why don't we just go over? This is on 2304 that I'm making this measurement, looking up at the sky. And you look at these numbers here. This is basically, I'm getting like a 60 dB level. And then when I go to cold sky, it drops down to 54 dB. So the difference between these two is approximately a 6 dB termination over cold sky noise. And so this is pretty good for that. It would be, well, what am I trying to say? It would be, it give you a good rough measurement if you have a problem or not. I don't know that you could ever get down to tenths of dBs, but I don't think we're interested in that. We'd like to know probably within a dB or so of what our termination of cold sky noise is, just for a reference for us and our system. And if you had a good number today and you're able to work people, and in a week or so you still had a same good number, but you can't work people, then it tells you probably have some other issues. But at least it tells you that you have a system that's capable of seeing signals, on the moon. Go ahead, Jim. So what are some of the solutions? A lot of times we need a fairly good high gain preamp out at the dish, only to overcome line loss, if you will. But that also does not help the intermod. So the intermod is really these 2x1 products that are introduced when you take two signals and you mix them together, and they provide an in-band response that you really don't want. So a lot of times what it takes is to add a good filter after the first stage, and also consider SAW filters in between L and A gain stages. And item number 2 is what the guys like Tommy Henderson do, WD5AGO and his preamps, and also the Demi preamps. I had a nice Demi preamp on 902. It's a 2-stager, and it had a SAW filter in between the 2 stages. And fortunately, even though we're being invaded on our bands, that does allow us to buy or find SAW filters, surface acoustical wave filters, that are actually designed for some of the bands that we operate in, like 902, 2304, and 5760. I'm not sure. I don't think they're readily available up there, but I might be wrong. The other thing is to put a good surplus cavity filter in between the preamp and the transverter. And they are available for 900, 2300, and 5700 bands. There's some for 10 gig also, but I haven't had a need for that. If we go on to the next one, Jim. This is the filter that I had to use on 902 at home. I could not operate the 902 band terrestrially unless I had this bandpass filter on the front end of my transmitter, or the whole rig. Actually, I transmit through it as well. But these, let's see, the loss is like 0.9 dB. So that limits my noise figure to about a dB over the transverter. But it's either that or not work people. And when I'm on the moon, I still have this filter in line between the preamp out the antenna and the transverter. So these are, some things that you may have to do if you're trying to stretch the noise floor down, if you will. Go ahead, Jim. This was a little 2 gig filter that um, I tuned up here for 2304. It's a nice little guy. It's got 1.3 dB of loss, and it's 60 dB down at 2100 and 2480. So this you can see here, this is a plot from 1 to 3 gigahertz. So 1 gigahertz down at the left side, 2 gigahertz in the middle, 2.3 gigahertz here, and 3 up here. And we get rid of all the PCS cellular stuff on either side of it. So these are things that you sometimes have to do. In fact, actually on 2304 at home, I have a filter. Most of these I've gotten from Kent over the years. It's a big filter, but it's on the front end of my whole system. And I had to do this because when I aim at 30 degrees towards Chicago, I'm looking through that cell tower. And Jim, this is the cell tower that you were interrogating there just northeast of me. So I finally decided I'm just going to stick the filter in and I'm going to live with it. And you know, as proof, it worked Florida the other day. So sometimes you just got to do what you got to do and suffer the consequences of a little bit less in the sensitivity area. But when you got a noise source that's 20, 30 dB over the noise, you know, you can make a choice on that.
Can I ask a question about that filter?
Yes, sir.
Did you change the screws on it to those longer screws? And then which way do you tune it when you start tuning on it? In the middle out or on the ends?
Well, it's a good question. It was a long time ago when I did this, but that certainly looks like non-plated brass screws. So I'm guessing that I probably needed more insertion than it was originally designed for. So I'm probably bringing this filter down in frequency, Bob.
Okay.
Yeah. Yeah, those aren't original, are they?
Just,
I don't
I,
think.
I just noticed that. I was just
Yeah.
curious.
Yep. Yep. Yeah, it probably was tuned to higher frequency. Okay, go ahead, Jim. So, in summary on this one here, incorporating a termination of cold sky switch will help the EME operator establish a norm for their system. When I get on the moon, I'm always checking this on, I'd say, well, all my systems. I always have some way of comparing termination to cold sky. And, you know, it's been real beneficial there. Any questions? All right, well, let's go on to the second one. It's kind of kind of an extension of this one. I think you don't think okay, another one. Okay. Trying to think of what let's see, what's the name of it? Yeah, okay, that's it. Yeah, I originally presented this back in 2012, and in 2024 we had some numbers, some updated sun noise numbers. I think we obtained these out at Bob Strickland's place when we were out there during the eclipse. In fact, I'm pretty sure that's when it was, February 3rd of 24. And I'm representing it here because I've seen some discussion on MoonNet about comparing dishes based on sun noise. And of course, that's two operators, two different antennas, two different receivers, all sorts of differences, if you will. And what I did here was we've used the same receiver for all dishes, so it was easy to make a comparison. But it brings to light some things having to do with sun noise at low numbers that I wanted to present. So let's just go ahead. We can skip that one there because that's just same noise meter slide. Skip that one. And this one, because we had talked about it. All right, here we go. The question is how do we compare sun noise readings? Well, you know, if Bob was getting 20 dB of sun noise and Al's getting 30 dB, you probably say, well, Al's system is 10 dB better than the other guys. And for anything over 20 dB, that's probably true. But when you're making a sun noise measurement in dB, you're really looking at signal plus noise over noise. That's what you're comparing. You're off the sun, so you're measuring noise. When you go back onto the sun, you're measuring signal plus noise. So when you take a look at this, signal plus noise to noise, if you break it out, it's really signal over noise plus noise over noise, which is 1. So therefore, signal to noise ratio, which is what we should be comparing, is signal plus noise to noise minus 1. So keep in mind, signal plus noise to noise is what you measure when you're looking at the sun. When you want to compare readings, you really need to be comparing signal to noise ratios. If you go down to this table here, you can see that 20 dB of, we'll call it sun noise, is real close to 19.96 signal to noise ratio. You get down to 10 dB, it's still pretty close, 9.54. But as you get down to, let's stop off here at 3 dB. If you're measuring 3 dB of sun noise, that's 0 dB signal to noise. That's because if you had 3 dB of sun noise, that meant that you had 3 dB of noise and another 3 dB of sun plus noise to noise. And in reality, they're the same level. The actual level of the sun is the same as the noise. I guess is the better way of saying that. So actually 3 dB of sun noise means that the sun noise is equivalent to the noise level behind it. So the actual signal to noise ratio is 0 dB. They're the same. It's unity. And they do add because powers do add. Just like if you had two 1 watt signals and you added them together, no losses, you're going to get 2 watts or 3 dB more. And if you're only getting, let's say, 1 dB of sun noise, that's actually a minus 5.87 dB signal to noise ratio. So you really need to compare signal to noise ratios and not signal plus noise to noise ratios. And you can see that from that table. We'll go into some examples. Go to the next one. Here is a graph of that same curve. Basically at 20 dB or so, they're about equal. 10, they're pretty close. 0 dB signal to noise ratio, that's like 3 dB of sun noise. And you get down here, if you're only measuring 1 dB of sun noise, that's only what, minus 5 dB or so signal to noise ratio. We'll move on to the next one, Jim. Now here's just a couple of comparisons or a couple of examples, if you will. If station A is measuring 20 dB of sun noise and station B is measuring only 10, then converting them back to signal to noise ratio, you get 10.42 dB or a change in sensitivity of 10.4 dB. Now, if you're comparing station C, who is receiving 10 dB of sun noise, to comparing to station D, who's receiving only 3 dB of sun noise, the difference there is nearly 10 dB for a 7 dB drop in sun noise. All right, moving on. This is just an expanded scale, so we can move on from here. Now, if you actually want to go through the math, this is basically what we're doing. If sun noise from antenna 1 was 2 dB and 4 dB for antenna 2, this is how we'd make the comparison. You take the 2 dB, you got to convert it back to a ratio. So you divide by 10, take the inverse log, subtract 1, 0.585, 10 log of that minus 2.33 dB. So it's pretty simple in terms of the math if you got a little scientific calculator. And the same with 4 dB. You divide 4 dB by 10, inverse log minus 1, and then you get a factor, a ratio. You convert it to dB, and you get 1.8 dB, and you just subtract the two. And antenna 1 is basically receiving 4 dB better than antenna 2. Pretty simple math, but you got to realize this is what you have to do when you have small dB numbers. Go ahead, Jim. All right, these are some measurements that we made back in May of 01. They're at 24 gigahertz. And hopefully they'll kind of send a point home a little bit here. It's the same noise figure, 2.4 dB, and this was connected to each one of these antennas. And you can see the antenna listed over on the left. And on a 12-inch commercial dish, measured 1.5 dB of sun noise, converting it to signal to noise is minus 3.84. And we're going to say that this is our reference, if you will. And this is a theoretical gain. And based on that, this is going to be our reference. So we're going to refer everything to the sun noise that we made with this antenna. So basically, if you double the aperture, which is what we did here, we're receiving 4.2 dB of sun noise. You convert it to signal to noise ratio, and then you compare them. The difference is nearly 6 dB. That's exactly what it's supposed to be. You double the aperture, you're going to gain 6 dB, even though you only gained, well, let's see, you went from 1.5 to 4.2 dB of sun noise. But in reality, that's almost 6 dB of gain. And that's exactly where you want to be. And we looked at some other ones here, like a PCOM dish. And it's close, but not as good as the MACOM dish. And Joel had brought his stuff down at the time, and we were looking at it. And we made some comparisons. And his dual band 10 and 24 gig feed on a 2-foot dish came in at 5.64 gain over the 12-inch commercial, pretty close to the 24-inch MACOM, specifically designed for 24 gigahertz. So the dual band feed actually works pretty well. And then we had a 55-inch dish here, and of course it beat everything out, but it's actually a bigger dish. But when you look at these numbers right here, it kind of gives you the idea or the impression that these numbers kind of make sense now, even though the sun noise maybe threw you for a loop, because you would have thought double the aperture, I should go from 1.5 dB to 1.5, 4, 6 dB of sun noise. But in reality, it's only 4.2 dB. But that's all you could expect on sun noise. But in reality, it's the 6 dB difference that you're looking at due to the aperture. Every time you double your aperture, your gain goes up by 6 dB. All right, let's move on to the next one here, and I think that should be about it. We did some very similar numbers. Of course, these are the older numbers. Probably don't. Yeah, these probably don't tell the story as well as the other ones do. Mainly because we're looking at we're looking at antennas here that are all about the same size, but you get some idea. The sun noise, 1.5 dB with a 24-inch dish, 1.3 with a 30-inch, 1.1 with a 24, and even 0.22 with a little offset fed dish. And when converting them back to signal noise ratio, then you look at the difference in the gain. So it looks like, yeah, you might say that the 30-inch dish I had here was not as good as the 24-inch dish. So this is the right way to make comparisons with sun noise, converting them back to signal to noise ratio, and then look at the dB, relative dBs. And I always put this down for reference because we weren't measuring gain. We were just trying to get some difference, an idea of the difference in performance of the various antennas and make comparisons. I think that's all for that, Jim. Can't remember what was after this one. Yeah, this moving forward, I think Jim and I want to do some tests at 47 and 122 gigahertz. So I think stand by for those events to happen. Especially would like to do 47 and 122 because those are two bands that we're kind of highly motivated to work on at the moment. Any questions on anything?
I have questions and comments.
Yes.
What about, so when you were making these measurements, you're using the same receiving system and the same frequency to make or compare all the different antennas.
Right.
Otherwise, wouldn't bandwidth and variations in the equipment that you're using make differences too?
Yeah, this is just all hooking up I think we're using like a 1 meter cable from the transverter to each antenna.
Okay, and then the other thing is the situation about how well the dish is illuminated could play a role here too, right? How good your feed is coupled with your dish.
Correct. And we were making some adjustments based on the sun noise numbers that we were getting from what I remember.
So you would get them reading and then you would try to tune it up while you were doing it to
Yeah.
make it more like what you thought it should be, I guess.
Except during the solar event.
Right. Okay.
Any other questions or comments from anybody? Well, hopefully I didn't bore you to death, but you can I think Jim's got them up on the on our website, or we'll have them up there shortly. I know the first one is already up there, I believe.
One other question. What about heating from the sun while you were doing this? Just the dish focusing heat on the
Well, yeah, I've cooked a plastic feed horn looking at the sun on 24 gigahertz. I've melted the little prongs that are holding the subreflector. So yeah, things are going to get warm, even with a small dish.
so you just have to do it quickly, I guess. Make your measurement and get off the sun.
Yeah, I mean, we don't use shiny reflectors for the most part. I mean, my 5 meter dish it was painted, and even my 24 and 47 gig are there's aluminum tape on it, but I painted over it. So as long as they don't reflect the sun's rays to do some cooking. But I had that problem with I think it was a 2 foot PCOM dish because I took the radome off. So I had a nice shiny surface and it did a good job of melting the legs on the subreflector.
Okay.
All right, Jim, take it away.
Thank you, Al. I think you can't give this presentation that you've just given too often. Every time I hear it, I learn something new and am inspired slightly different ways and kind of just renewed in an effort to use those principles and put them to real use in trying to make improvements. All right, we'll drop into this one now. This is for some of you that were in Lincoln, Nebraska a couple of weeks ago. It was 2 weeks ago. This is a little bit redundant until we get near the end, where there's new learnings as the work is continuing to design and develop and produce a set of working beacons that are capable of digital modulation. I am working with another person on some of these millimeter wave um, trials, and so there'll be more information coming as we go there. So jumping in here. First, we want to just cover briefly the list of beacons that we have in the North Texas area, and the fact that this is a very important resource for anybody in this area that can receive or within range or even slightly beyond range. It's not always possible to, receive a beacon or detect a beacon until propagation swings in the right direction for you. So I did want to note and draw your attention to the frequency reference used here. And you see a lot of them are sitting on 10 megahertz OCXO. And then there will be, a little bit different frequency in use. The 108 00395 is probably a little more common. We recognize some of those, but RF0 comes into play in kind of in this area, so you'll see how that works. We currently have beacons all the way through 10 gigahertz. Greg is working to upgrade the beacon at his location, Alpha Alpha 5 Charlie, near the bottom of the list. And we have plans to place another 24 and 47 gigahertz beacon into the air. There have been some discussions about possibly having a pair of both of these, one to the south side, namely kind of in my area here, south of Fort Worth near Burleson and Alvarado, as we're picking up members that are moving west and south, and this would give them an intermediate stopping spot to, pick up a beacon and tune their systems. So what got us here is that as we were strategizing to add higher powered millimeter wave beacons that can be remotely controlled, since we don't really think we have to run them 24/7, our plan came around, first of all, the easy one, which is to use a WaveLab 24 gigahertz system, because I have guys send me back boards here that they say don't work right. They, sometimes they want me to fix them. Oftentimes, if I have spare boards here, I just build another board for them rather than try to sit there and figure out what's wrong. And so I got a pile of them, and so it's pretty easy to find one that still has a transmitter side that's working fine. And so the idea was to drive a WaveLab with the 144 megahertz signal, just like an IF. It would be the IF, and it would generate a CW keyed string through an Arduino. And then on 47 gigahertz, our plan was to use Tom's WA1MDA quadrupler, which we obtained in a few years ago in I'm not going to remember the name of the city, but it's in Connecticut, where we gathered for a combined microwave update and VHF conference. Tom brought a stock of those, and Al and I both purchased them. And so we drive that quadrupler with a DB6NT LO that's around 11.7 gigahertz, and it just quadruples it. There is a CW string loaded into the DB6NT LO, so that's how we get keyed output. In between, there's a carrier. And then there's an Arduino controlled hologram card for remote control, so the cell phone app can turn either beacon on or off. Then we learned about the thing called the RF0. So this is one of those projects that kind of gets drawn out because there's advances, and you go, well, maybe this is the way we should go before we bolt it down up there for, years and years and years. And so it's hard to draw a line and say where we're going to stop and with these ideas and, commit and get it done. Anyway, you can see the potential design change from the left side, which is what we have. And that part was running aside from we did not have a PA on the 47 gigahertz. But this left side, was working. It's sitting here, and we'd deploy it, and Al would listen for it, and others would listen for it. But now we're moving more over to this diagram on the right side, and there's still design decisions being made around what's the best way to do this. And I'm going to sit here and break this down. Here's the RF0 board. For those that don't know, the GPS is on the left side, the Neo 7M. And the ARM M0 is kind of directly 9 o'clock from center. I guess my cursor may show up. So it's that chip right there. And it provides a lot more I/O pins for use, which is one of the things you'll notice here. There's a 16K EEPROM also. We'll explain some of that usage. There's a set of jumpers here, kind of in the above the chip, which can be used to take out different voltages for LCD use. You'll see lots of pins that are. It's possible to stack a board on top of this, and Bo, the kind of the spokesman for the group of RF0, he sells those boards so that you can stack like a daughter board and mount other stuff on it. It exhibits a power control IC. This is a stack of 8 Darlington pairs, which you can drive with the Arduino, and then they basically could replace a relay because they can sync 500 milliamps apiece. The RF section's over here to the far right. It is an SI5351A, capable of basically 10 dBm output from about 270 megahertz down to a very, very low frequency. There is a TCXO on here that's 27 megahertz that the chip is tied to. And then there's a transformer here that you can add I and Q on these pads. And then there is a set of filter pads here that we'll talk about. But basically, in this configuration, they're all shorted so that whatever's coming out of this chip is going to go right out through this port. There's some signal LEDs across the bottom. The middle one ticks on the 1 PPS from the GPS. The one on the right is just a all good power light. And then the red one blinks with the modulation of the beacon itself. And then there's a USB port for programming down here. Some beacon modes, which is where we get into some of the functionality of what they've done with this. Now, it is, you might say, open source, because all of these beacon programs are nothing more than Arduino sketches. There is a library that has to be instantiated if you use the integrated development environment. But they also have a client configuration program that I'll show you. And that's the simple way of downloading one of these type of programs into the RF0 Arduino and then tweaking it, i.e. configuring it. So here's the 4 modulations. I didn't list them all. There's a PI4 that's very popular in Europe. I didn't list that one, and there's some others I didn't list. So I did think it was cute that they added RTTY down here, which is, I think, kind of a tongue-in-cheek. But somebody might actually want to listen to 5 strings of RTTY out there and check out their RTTY demodulator. There is Whisper. That's one of the first things I did, was just poke a Whisper sketch into it, pick a frequency, hook it up to my long wire here, and away I started getting reports, started seeing the reports. There's frequency compensation for multipliers up to 72 gigahertz, supposedly. We've run some tests. That was part of the purpose of this paper and presentation. Here's the configurator, or the thing called the RF0 Manager. You can see that on the right side, the selection's been made for Q65CW plus carrier. You double click that, it downloads it into the chip once you're connected here up the upper right. In this configuration, you'll see that the nominal beacon frequency has been programmed at 144 0.00000. So right away you'll see millihertz potential. And then on and off keying for the CW portion of the beacon string. There's the data that will be sent, and the Q65 mode is set to 6. That's probably 30B. You can type in a question mark here and get an explanation for all of these parameters that are configurable, as well as how to write the new frequency or the new parameter that you want to write. There's a lot of thought been put in here to try to make this easy and simple. Oh, well, here's the help page that I was just talking about. So what did it say? It said mode is 6. So mode 6 is 30B as shown up here. So the first objective was just check the tone spacing, particularly through multiplier or harmonic. I had that in my head. It's like, how is that going to work exactly if we're going to use harmonics or we're going to multiply this stuff, which is pretty much like a harmonic, right? So, but there are fundamental differences. So I noticed when I programmed in what I just showed you, 144 megahertz, I was getting 100% decodes. There was no problem. I took the thing way out in the yard, about 300 feet away, and the signal was still, -3 or 4, something like that, and it was decoding. Of course, I had attenuators on it, no antenna, and I did everything I could to try to reduce the power of the thing. So in this case, the 144 megahertz signal that was programmed on the preceding page is not using a harmonic. It's one of the, it's below the 280 megahertz that the chip can produce. I won't contest that there's probably other sub-multiples inside the chip. I also saw proper timing through the GPS clocking and no drift, at least while it was in here. I don't remember that it drifted when we took it outdoors. So studying the Q65 Quick Start Guide, I saw that on B, C, and D, there were 30-second period, there were these different bandwidths ranging from 433 hertz all the way up to 1733. So I just started with Q65B since I had it programmed in. And just a side note that we have made contacts using Q65B30 on 24 and 47 gigahertz. These were made rover to fixed station, where both stations were using WSJTX Q65B30. So the idea that, hey, let's make a beacon that can do this seemed very viable, since we'll get our signal to noise numbers and just have a whole nother level of a weak signal experimentation. I used a 10 megahertz referenced HAC RF module, and an SDR console was used to make observations of tone spacing. So I just want to stop a minute and just say that I used 6 dBm 10 meg reference from the Spectracom ageless GPSDO as input to the HAC RF. You got to be careful here. The clock in port on the HAC RF is a high impedance input, expects 3.3V square wave at 10. Do not exceed 3.3 or drop below 0. And there is a Linux command to configure clock in and verify reference clock signal detection. And I showed that down here near the bottom for those that want to follow suit there. So here's the tone spacing. Looked like it was right. I calculated, I looked at the chart for 65B, C, D, and then outlined here the they're not the sync tone, but the other tones and their bandwidth, and they checked out very good, and they also decoded. So we moved on to harmonic testing and working to understand the multiply feature in the documentation. Setting the SDR to receive at 1296 and keeping all the same variables as the last test, which was D30. We expected to see a 9 times spreading of the 1733 hertz, i.e. the ninth of 144, And that was confirmed with observation of approximately 15.6 kilohertz. Here's that look. So no surprise, you're going to work with the ninth harmonic. WSAT is not going to be able to touch it or decode it because it's way too big. So digging into the documentation, we found that the correct method for programming 1296 is to write the configuration frequency as 1296 and let the RF0 program library do the work. The calculate tones multi-function, that's a library function, contains the math that resolves the tone spacing and bandwidth and selects the appropriate frequency under 300 megahertz to drive the RF synthesizer. So here you will see the program input of 1296.000.000 has derived a multiplier of 7. So the multiplier at 1/7 of this frequency turns out to be 185.14. That was confirmed, but first I'll show you the correct tone spacing of the 7th harmonic. It's all in line now. So I also said, well, okay, that's good at that frequency. Let's take 10.368, 360.000, see how we end up there. It said, okay, I'll just take and produce a fundamental that multiplied times 47 times will bring you in on the frequency you've asked for. So here's the key point to be made here. When the software selected 47 as the multi, it knows to, I'm going to use this word, squeeze or squish or reduce the Q65 tone width and bandwidth to 1/47th of what will be required after this thing goes up all the way through 47 times multiplied. So here is that fundamental, 22603.4, right on the money. That was what was, well, I didn't put the calculation here, but that's going to be 10.368, 360.000 divided by 47. Good, strong signal right there. So now what about the harmonics? Because there's a lot of them. So there's these pads on the output section of the board, and there's also some standalone PCB boards. It's regular FR4 board. And so we tested both. First was a bandpass filter from 100 to 150 built directly on the board. So I wanted to introduce this to Central States and to you also in case you haven't done this or you don't have a favorite tool. I know many of you are very advanced and have your own tools. But the LC Filter Design Program is free. It's referenced in the references. Has a lot of good design features. I know Markey has one now too. LC design parameters for the 100, 150 bandpass filters are as follows there. For a min of 100 to max of 150, you can see the values for a handful of capacitors and a few inductors. I did draw out a KiCad schematic just because this is going to be one of the things we're going to talk about in presentations, how to use KiCad. And I just wanted to throw a teaser in here. So here's what those previous values look like mapped into a schematic. Here's the theorized plot. So you can see if it performs like this, it's going to be a real good, effective 100 to 150 megahertz BPF. So here's the before filter. In other words, here on the left side, we just got the shorts as it's supplied default from Denmark. And now down here in the lower left, you can see all these harmonics to be dealt with. And 432 is pretty hefty. And then there's some others that are down 30. So they're pretty strong. Over on the right side, I've placed the SMD parts on this is the onboard filter. So I've got the parts on those, all 0805 size, not hard to put on. And then you'll see the result down here on the lower right. We've still got a good strong signal at 144, and we've suppressed everything else. The 432, third harmonics down 40. Then we built a 400 megahertz high pass filter, which would suppress below 400 yet allow harmonics above. Uh, and so here's the board on the left as it's supplied by the boys. And then here on the right, there's my job of soldering on the SMD parts. Here's the LC design. This is the schematic that LC can show. I couldn't find a 130 nanohenry, but I did have some 120s. So I stuck that one in there. Here's the plot. 400 high pass filter. I do see some dipsy doodles in the return loss, but it's probably not going to affect anything we'd want to do. So we programmed in 432.300, and this produced a 144.100 fundamental that was at 14 plus 14.1 dB. I've got a 20 dB attenuator on here. There's no corrective factors here, so you see the far on the left that tall line at 144 showing down by right at 6. So that's plus 14 dB output from the RF0. The 432.3 harmonic is down 7. Now this is without the filter attached. So this is, by the way, an Tiny SA Ultra, the PC control program. That's a nice feature. I love having a handheld spectrum analyzer. If I had time, I'd tell you how I found my phone today using it. And so then you go to the next page, this little feature shows up because you see still got this blue line from the original reading and measurement, but now the little light colored cyan line is the current reading. So we have the external filter screwed on. The 144.1 dropped 57 dB. The 432 harmonic is down 18, so it dropped 11 dB. I think the insertion loss was stated at 10 dB. So this is what I got with kind of a quick test, unoptimized test, just to show that the high pass filter would bring us more in line with where we want to be. There's nothing stronger than minus 45-ish. With 20 dB pad, then that's minus 25. So it's still, some of these are still a little high. There's the test setup. So you can see the external filter here hanging off the right, coming off the non-modified RF strip. So let's get to how we did the 24, because this thing's working and it's been copied, and we hope to amplify it a little bit and make it more useful. But we used an RF board with 100 150 megahertz bandpass filter, programmed the RF0 to 144.360, observed 10 dBm output. We programmed the mode to use Q65B30 carrier and CW, which turns out to produce digital the first half of the even minute, carrier the second half of the even minute, CW string first half of the odd minute, and then the remainder of the odd minute is carrier, and then you go again. The secret here was to inject the 144/360 megahertz signal ahead of the WaveLab mixer. Forget the pad, forget the input IF connector, just find the capacitor to take out and use one of those pads right in front of the WaveLab mixer. This drives the WaveLab to full output, at least what I'm getting, 31 dBm at 24/192/360. There's the capacitor to remove. Just put the drive right on that pin 5 of the mixer, and away you go. Now you got to put the WaveLab into transmit mode, of course, so that this TR switch over on the far left will go into transmit and drive the mimic that follows and then goes into the module. We got to empirical testing just before the conference, and this is the kludge that we currently have, and it's out. It's actually deployed this morning or this afternoon for anyone to listen to it. We use a W1 gigahertz sector horn for both 24 and 47. It's the exact same model. It's going to be 9 dBi on 24 gigahertz. It's going to be about 3 dB better on the 47 gigahertz. You can see the quadrupler for 47 hiding behind right here, an arrow pointed to it, and the Cooney LO And then there's a sandwich down here on the bottom consisting of the WaveLab module, the WaveLab control board, and the RF0 board supported above that. So here's looking right up at it. The zero board and WaveLab board modules are sandwiched there. And there's a perturbation shield over the 27 megahertz TCXO. Then we went out and using the trailer mounted telescoping mast. The beacon assembly is raised to 30 feet, and the signal was strong at 60 clicks and decoded 100% by Al Ward W5LUA. This is a path from Grand Prairie near the I-20 and 408. I know some of you have operated from up there, and it's got a nice launch for a few clicks. And then Al's over here. This is giving him his 60-ish feet of tower-mounted fly swatter. I think he's using the fly swatter on this. And I rotated the beacon 180 degrees. He said the signal was still decoding around minus 23. So this illustrates that very broad pattern that the sector horn has. It's really only down 10 dB straight off the back. So it's a pretty amazing, almost omnidirectional. And Al did take a video of this, and it's available at the references here. Here's this guy up in the back of the pickup truck. I actually tried to work Al on 47 that day. Didn't work, but that did have these cedar bushes to deal with. And you see the beacon is up high in the air. So our conclusion, and I have modified the second page of this since the conference with new learning. But this group has been around a long time. The board's been around a long time, been many years. I haven't seen it implemented a whole lot in the United States, although there are selected users and use cases in production or in use. A large group exists. The company provides very prompt responses to questions. New releases of the Arduino script are made when corrections are found or improvements are found. There's been a very latest release just here back in May, and it has a function that's very important to our purpose. Now the multiplier is manually configured, so you have now at your disposal the controls of the fundamental frequency plus the multiplier factor. They exposed that as a configuration item. I changed these first two bullet points here. Stability is sufficient to enable digital modes in VHF and UHF with attention paid to shielding the crystal. For microwave frequencies, use a transverter principle where the RF0 IF signal is below 280 megahertz. NTMS will implement the power control IC, the onboard GPS, Arduino C++ coding so that we can just keep everything in one Arduino instead of having multiple Arduinos. And if we place a south beacon in DFW, then I want to add 10 gigahertz. Why not? So now we need 10, 24, and 47 driven by RF0 beacon boards. So let's visit more deeply how the RF0 produces the WSJT tones when considering various mixer and multiplication strategies. That's where it gets to be fun. First of all, Bo sent this to me about a week ago. There are these different application principles. The first one here, I wrote a crib sheet for this. The first one, titled A, is simply an RF0 that you could employ on HF. You could have a whisper device, a whisper transmitter. You could have a 10-meter beacon. And it's pretty simple to understand. You just program it in, it spits out, a single frequency. You might have to add a filter, to clean up, make it friendly, especially if you're going to go on 6 meters. This would also cover that use case, 2 meters or 222. As soon as you go 432, now you got a harmonic and you go to B2. But, B1 could handle what's the difference between a multiplier set of stages or a harmonic? Well, multipliers are usually doing gains and filters and gains and filters, and the harmonic isn't. But so B1 and B2 are very similar. They would cover everything from 432 to 10 gigahertz. And I'll show you what happens in B2 when you get it out on 10 gigahertz. C1 is the transverter principle. This is how we're doing the 24 gigahertz Wavelab. C2 is what we plan for 47. I've got the details on that, but it'll involve a stable LO at the mixer stage where we are going to take a very low signal, supposedly very stable signal from the RF0 and mix those and then multiply them. The objective here with Tom's quadrupler is derived at something like 11,772 and change. That will then be multiplied 4x. C3, I haven't found a use case for. So the B2 example, this is a little sloppy, and I'll tell you that we won't be using it, but I can see how the PI4 beacon probably work just fine with this, and I'll show you that this is decoding nearly 100%, even though the frequency corrections are obvious, as the 1 PPS is taking a look at the current RF frequency of the SI chip and then supplying a corrective component to swing it to be a more accurate, or what it was intended to be, what it was programmed to be. So in short here, this was programmed at 10,368, 360 odd with a 47 multiplier. That produces a fundamental frequency of 220.603,404. And to reinforce again, the Q65 tone width and bandwidth is 1/47th of what we're going to require when we get to 47 gigahertz. So Al, pay attention here. This is the result. So transmitting over the air from about 300 feet away outdoors. This is the 10 gigahertz signal. It is the 47th harmonic, and it's decoding almost 100% of the time. As long as the tolerance, you see the tolerance up here is only about 200 hertz wide, but as long as this signal doesn't drift any further one way or another to get out of this tolerance, and I ran this for 24 hours. It never got outside this other than a couple of decodes. You can see over here on the left, it's working quite well. I think this is a 60-second mode. But you can observe some what's probably phase noise in here, and you can definitely see the corrections taking place. And I know we can do better. Here is that 47th harmonic. It's right on frequency, but it's got some skirts. So this is the B2. Here's how our beacon is set up, just so we can cover it in this nomenclature. The LO frequency is 24048. It is locked. The RF 0, which would be our IF frequency, is 144,360. The final output is 24,192.360. The multiplier is 1. So the Q65 tone width and bandwidth is in the required mode at the fundamental frequency, and it's simply mixed or added to the LO. So there's no multiplying going on of the IF. I'll go into the double mixing stages on the next slide because the story's a little deeper than what this slide right here shows. Here's really what's happening. I got to scoot these pictures of people out of the way. All right. So in the Wavelab implementation, the 144 megahertz IF from the RF0 is mixed with LO2 on the control board, which is 2220. That results in 2364. And you'll see 2364 comes in where you see TXIF input. That's where the 2364, it's met by a filter, a ceramic filter right off the bat that happens to filter a bandpass filter at 2364. Then it drops down into an up converter, and what it's making mix here is the 21.828, say that again, 21.828 megahertz, which is LO1. It's actually 1819 megahertz multiplied 12 times. So when you mix 2364 with 21.828, out comes 24,192. And that's what this red line is doing here. Now, the blue line is the 1819 going through a multiplier of 12 to get to where it's mixed up here. So the key thing to remember here is the Q65 modulation is never multiplied, only added through mixing. And that's why you go with this multiplier of 1. Here is that spec. So you'll see the injection frequency is 144.360. The multiplier is 1. Now, I'll remind that now with the newest version of RF Manager, you have control over this multiplier. The 10 gigahertz beacon, this is on the bench back here. I don't have the last component, but the main driving pieces are working good. I have very high confidence this is going to come out all right. So the story here is that we get 3255, which happens to be one of the dip switch selectable frequencies on the Digi-LO. So if you'll take that 3255 and then push that in as the LO into this mixer, and then bring in 201.120 from the RF0, out comes 3456.120 on the RF port of the mixer, which the plan is to go into W1 gigahertz multiplier, LO multiplier and filters. And we were kind of talking about these principles before the club meeting started, but we overdrive this ERA1. It says ERA2. I ordered ERA1s and 2s. But anyway, we'll overdrive this and hopefully get a third harmonic here into this first pipe cap, where we can begin to clean it up and then amplify and clean it up further for the 10 gigahertz signal. And finally, one more multiplier stage. It might need a second filtration stage. Right now, what I'm reading out of this mixer looks really good. It's got some problems, but it's stable. And that's what I wanted, was to lock in the stability of what the Digi-LO provides and take advantage of using a very low frequency on the RF0 for other, equal stability reasons. So the one takeaway here is the Q65 tone width and bandwidth is 1/3 of the required tone width and bandwidth at the fundamental signal. So if you were to look at 201.12, all the tones in the bandwidth would be 1/3 of what they need to be. And then after multiplying that times 3, you're on target, and the theory is all is well. So here is the programming: 201.120.000 multiplier of 3. All right, moving up to 47 gigahertz. Now, first is the Cadillac version. I'm just positive this one will work, but there is more cost, but probably low in band spirit. The LO would be 11.500. That comes via a locked Cooney LO. The mix would be 11.500 with 272.090 from the RF0, which is the IF. Mixer out would be 11.772.09. Multiply it 4 times, out comes 47.088.360. The current beacon right now, as such, is using the Cooney LO at 11.772.09. The multiplier in this case is 4, because after we get to the front end of that quadrupler, we're going to expand all the tones and the bandwidth of the Q65 by 4, a factor of 4. The very last line, Tom's quadrupler for 4x input, 11.7, I think he says 10 to 12 will get you 45 to 50 or something like that. I know they've actually been driving that quadrupler up into the 70 something gigahertz range too. Here's a lower cost. I'm working on this one myself. I expect there'll be some phase noise. I'm not sure if it'll be acceptable, but I'm planning 3.H3333 through an ADF 4351. Take the third, that'll get you 11,500, and then we're right back on the other program of driving the multiplier. Multi will again be 4 here. This would be cheaper, but it may not be acceptable from the phase noise standpoint. We'll see. Here's a kind of a quick snapshot of Tom's input versus output kind of thing. So you see he's got wiggle lines over here for 0 input, plus 1, 2, 3, 4 dBm input, and he's got it right on the 47 line here with this marker. And then on output, you'll see he's showing between 10 and 15 dBm out. And again, that's with oops, touched something I shouldn't have touched. Okay, I guess I don't know how to read that. Here's the references. If anybody's interested, this is on our website. Any questions? All right, then I'll move on into the next one. I'm sorry if I can't get through these quick enough. Test plans. Okay. Contest is upon us. I guess we have today and tomorrow to do any other tweaking. Here's what I know of as far as the fixed and portable and the rovers. Of course, I know Al and probably Greg, Keith for sure, Paul Perryman for sure, WA5WCP, possibly Wes, W5AFY. I'll call Scott a fixed/portable. He suffers like a rover, but he doesn't have to burn gas. I guess I could put it that way. Here's the rovers I know of. Brad has said he's not going to tolerate heat, but he might go up to Bob's place, W5FKN. Pat said something about maybe being available one of the 2 weekend days next week when we were talking with him in Lincoln. Matt, our club vice president, W5ZCA, says that he could possibly get out, and he is now out to the west in the Brownwood area. Steve, K5MNZ, has given us his locations, and I'll share those with you. Myself and KI5EMN will be traveling together. I'm not sure of others. We will solicit their plans through the emails and see what else might be going on. Here's kind of the traditional schedule we've published before, give you an idea of where we're going to be. I'm going to add the K7FRY links to this, and then I'll get it spread around, published. We generally will give you the 10-digit over here, and then what day, Saturday and Sunday, and then we have the above sea level altitude just for kicks, and then we list our key targets with Al, Greg, Scott, Wes, and then I've got another page of them here. W5AFY, WB5ZDP, and we list the beacon. That's for our use, is just to tell us where to point to listen for the beacon. We have the distances, the as to the DX station, and the as from. Here's Steve's schedule. He's kind of in EM12 world and looking to gain some confidence in his pointing, and just when you go through a string of no contacts, it eats at you. It's just like Al was talking about too, or alluded to. It's like, well, what's wrong? Is it me? Is it conditions? Is it my rig? Did I burn up something? And so there are those basic principles of checking for the noise in the receiver, checking the weak signal, getting the pointing right. And I worry about crank up towers. I worry about things that move. Yeah, I know 1 degree can make all the difference. 1.5 for sure. 2, you're out of the ballpark. 3, you're in a different country. So it cannot be emphasized enough how important pointing is, and that goes for as and L, equally for L. All right, here's the rules of engagement. We use Slack. We'll go over from the general channel to 10 gigahertz and up contest channel, and you may want to split off to Chord 1 or Chord 2. I just got taught today how to find those. You return from the general page. There's a back arrow, and then you click on plus add channel, and then browse channels. And when you hit that browse channels, it will show you all of our channels because there's about 10 of them. Locate coordinate 1 or chord 2. This is when things get real busy and hectic and you want to peel off and go to the side. As activity increases, QSY with your partner to 110, 120 or higher. I prefer to work out all 10 gig stations before moving up to 24 unless it makes sense to complete 24s while waiting on 10 gigahertz stations to free up. So for me, be prepared to hear a QSY to 24 gigahertz once we complete on 10 in the contact itself. Here's the contest periods. Participation of 42 hours of operating time in each of the weekends. Logs are due no later than 30 days after the second weekend. Bands and modes, use any amateur band from 10 through light. Contacts made in any mode. That includes digital. See station and equipment restriction rules for restrictions on contacts made above 300 gig. Entry categories, there are 2 entry categories, either 10 gigahertz only or 10 gigahertz and up. There's no sub-power categories. Contacts with any station may be made via terrestrial, no EME, aeronautical, satellite, at least 1 kilometer. Stations may be contacted again on the same band if either station is moved to a new location, defined as a straight line distance of at least 16 clicks or 10 miles. Straight line distance. Duplicate contacts with both stations in the same location may not be made on both weekends. You burn them, and then you're done. Send a 6-character Maidenhead grid square locator. A signal report is optional. Each contact counts for distance points multiplied by band factor and QSA points as follows. Distance in kilometers between the center of the grid locator for each station multiplied by the band factor. This is not 10-digit to 10-digit. It's center of the grid locator for each station multiplied by the band factor. Here's the band factors, 10, 24, 47, 75, and 122 and up. They get multipliers as such. Each unique call sign word per band counts for 100. This is a bonus. QSO points are not multiplied by the band factor. Portable indicators added to a call sign are not considered as making the call sign unique. And the final score is the total distance points plus total QSO point. So here's a serious slide I want to draw your attention to. I am a rover. Been doing it for several years, very dedicated, very active. I want to remind you that the rovers and portable operators are in the elements. When conditions reach an unsafe level, then activity will pause or stop. Some of you know my partner got heat stroke a few years ago, and we were operating in over 110-degree heat. That shall not happen again. Every person has a threshold which may vary for tolerating the heat. I have a comment on the dangerous levels. I wrote up a paper to the ARRL in September 2023 regarding dangerous operating conditions, asked for consideration and pivoting the contest dates in August to the first week of September. I guess I didn't realize that there were people that were just able to dig into their snowbound mountain locations about the same time that we're griping about the heat. So we're not going to change these dates, at least at the national level. I want to ask you to bear with us to understand the prioritization that rovers need. The longer we stand in the sun sending dashes, the more we will be limited to continue. It's an equation. If I'm sending dashes for 5 damn minutes, that's 5 damn minutes I'm not going to be able to operate. I guarantee you there's a line we're going to draw, and that's going to be the end of the day. And if I have to keep sending dashes every single time I stop, how long do you need it anyway? So that's my third bullet point, and this is my famous speech. Do not romance the signal. Don't sit there and hit that rotator back and forth trying to get one more dB. If you hear us, we're done. Just take what you're handed, complete the contact, and move on. It's about running and gunning when you're out there and it's hot. I can tell you that not everyone will have this expense that we have on our plate, but a typical high-end Rover weekend will run over $500. We're going to drive 700 miles. We're going to have to eat 5 times. We're going to have 2 nights in the hotel. Totals up 500. When it's all over, then here's what we earn. We celebrate, tally your scores and brag, reflect on the learnings. I try to write them down as they're bashing my head in. Plan your improvements and send in a story to share. Questions?
Jim, I have a comment and a question. If you could go back to your slide that talks about straight line distance between grids.
Yes.
Can't remember what it was titled.
That's actually from the ARLL rules.
Well, that's what okay. Okay. So straight line distance, but says nothing having to do with the six-digit grid square to six-digit grid square, does it?
Yeah, it's the center. It's the center of the 6-digit square to the center of the. Oh, wait a minute. I know. I see what you're saying. No,
You can't straight line the center of a 6-digit
no,
grid square, can you?
no.
Or you're not going to do that on the fly.
A straight line distance could most definitely not be anywhere near the center of 2 grids. It could be from one corner to another corner in another grid.
I was just trying to think of what I think we kind of ran into that with Bart last time. There was some brouhaha, and I thought it had to do with not moving far enough.
Well, my locations that I have, I promise you, are 10 miles or more. Most of them are more.
Yeah, but somehow they thought differently. But I mean, we are always doing 10 digit to 10 digit. We always know the 10 digit.
Yes.
And 10 digit to 10 digit, if it's 10.1 miles, that's good. Or are they going to look at it differently?
We don't give them our 10 digits. We give them the 6-digit.
Yeah, I know, but I know your 10 digit and you know mine. And we put that in the K7FRY and we know it's 10.1 miles. Do we go with the 6-digit grid squares that are, the sub part of the 10 digit? We could get in trouble there.
Well, when we report in our logs, we are reporting the 6 to 6.
What you're saying, Al, is that you could have 2 10-digit squares that are 10 miles apart, but the 2 sixes don't reveal that. Is that right?
Right. Yeah.
I'm sure that exists. Are you sure? Sure. I think we just have to do some math on that and test. But I think their audit is probably finding the center of each of those 6-digit grids and then saying, what is that distance? And that distance better be 10.1.
If the first 6 digits were different from the other guy's grid, you're good, right? Wouldn't that be the case?
I would think as long as you're going from, let's say, Echo Mike 12AA to Echo Mike 12AB, you're probably all right.
Yeah, that's my assumption. That's the way I read the rules, right? With the if you PM5NZ put up a schedule, and if you look down his list there, if you were to get 4 people into those grids, and then you're all to score for the contest, EM12 112 EM12 LD is different from EM12 ML. Likewise from IL and IR. So you're good. You meet the contest rules.
Well, all of these that are in this presentation are well over 10 miles straight line distance.
Yeah.
We've done this for years, and so those locations are well vetted. But I think to whatever Al's point was there is that we need to study it and find the exception if there is one, because you're remembering that we got in some kind of a dispute, right, Al?
Yeah, that's where I'm coming from. I'd have to go back and see if I still have some of the emails. But I think it was the robot that rejected it or something.
Yeah.
What it says is, can you move around within 2 6-digit grid squares and obtain 10-mile separation and keep making contacts?
Oh, you can't do that.
We're just going to pay more attention to that.
You got to change from one grid to the other, like AA to AB.
Yeah, somebody got to move.
Yeah.
Mhm.
So, Jim, was a slide where you had all the places you're going to go, what you're going to do this year, the upcoming plans?
That's what we're going to do. I'm not sure I know what your question was.
Well, that's the plan for this slide right here is what you're planning on doing.
Yes.
Coming up
Yes.
But the do is, you changed it. Said 2026 before, but never mind. All right. Sure.
Oh, maybe it says that up here. Yeah, it says 26 of it.
Yeah. Gonna go a year in the future.
Yeah. I hope to be here.
Yeah.
Okay, good point. I'll change that. But yeah, this here you're listed on this one. So we'll go out to Red Springs and spend the night on Friday and then roll up to the north. And then on Sunday, we'll go back out to Abilene in the west and come up to Archer City.
Look forward to it.
Yeah, me too. Well, there's a couple of locations here that might have potential for 24 gigahertz, at least with the guys that have it on the tower. All right, I'm going to go on just to not delay, and I am kind of bugged by that question. I want to get to the bottom of it so that as a rover myself, I can teach it to others and keep it on the level. All right, let's keep buzzing through this agenda. I want to remind you about the phishing emails and scams. I haven't seen one or heard of one for probably a month or 6 weeks now. But just know that NTMS officers or prominent VIPs, I will put it that way, men that have served the society for many, many years. They're not going to reach out through text or email and ask you for money or even perform a suspicious, out of sort act. They're not going to do that. But your actions to take should be, if you're concerned or you want to report it, contact the person directly. And if you can, report, if it's an email, report it as spam. Let me enlarge this. Yeah, here's an actual email. This is back in June 13th. Looks like I sent an email to WA5TKU, but I don't have an email that's QWERTY3321. Most of you know my email. Moving forward, August. Well, tomorrow, this is Bob's world, I guess, in the West, but got to get up and look at the planet alignment. Every day I take 67, Tuesday through Thursday. I take 67 south and then all the way up to I-20 going to work. And so I've been watching this Venus and Jupiter spacing close every day. The 12th is the Perseids meteor shower peak. Brings back many nostalgic memories for me. 16th to the 18th is the contest we've been talking about. Woohoo! The 16th and 17th is an overlapping 2.3 gigahertz and up EME contest.
We got a question on the 10 gig. It says it starts at 0900 UTC. Do I interpret that correctly? That's 4 in the morning here?
Yeah, that would be the math, right?
Yeah. See you then.
No. There's nothing more frustrating than trying to set up a rover rig in the dark. You've got to have headlights and lights and take very careful steps. Okay, September. We'll have our microwave activity date. This will be the last testing day before part 2. And I've written, is there a potential for an antenna tune-up here on the Sunday following? We've got to talk about that because we've got some objectives there on the bands that Al mentioned. And there may be others that want to participate with that. The 9th will be our September Zoom meeting. MOTS Kilo Delta 5 Foxtrot Zulu X-ray is manufacturing WR42 to SMA transitions on his CNC machine in his garage. And he's measuring them for return loss and marking the return loss value on the transition. I'm going to go over to his place and basically document his procedure and interview him, take some pictures and so forth, because these are some very nice looking transitions and his measurements are in the 27 to 28 dB return loss area. Next, Bo Hansen is telling me he's going to try to make this happen. We're going to confirm it when the time comes a little bit closer. But he's got an agenda for the RF0. He can explain the library, kind of the interfacing through the Arduino IDE, which you don't have to use. But if you want to have complete control over the sketch, and some of you know what I mean by that, where you may want it to perform other functions while it's doing its other work that it's intended to do, then you'll need to be in the IDE. And he'll go over the example programs, how to load them, modify them, troubleshooting steps. And we're always looking for more presentations. Then the 13th and the 14th is the 50 megahertz to 1296 megahertz EME contest. I think that would be a wonderful time that if you've got a dish and you think it's big enough to get out there and see if you can hear these guys, because there's not going to maybe a better day of finding a bunch of people together. 20th and the 22nd, or through the 22nd, is the second part of the 10 gig and up contest. October, we have a MAD day. Then the Zoom meeting will go on the 11th, and then 17th through the 18th. I'm calling it the International Microwave Update because it does have international scope and participants. That's going to be held in Tucson, Arizona. Exciting times. Here's our perpetual items. The 2-meter net at 8 p.m. on Sunday, called by Ross Kilo 5 Zulu Sugar Juliet. The 6-meter Hoot Owl net on Saturday night, that would be tonight, on 50.125 at the stroke of midnight, from Al, Whiskey 5, Romeo Lima Golf. The NTMS lunch, which meets every Tuesday at 11:30 a.m., Texas Smokehouse Barbecue in Richardson. Then we have activity nights on 2 meters on Monday from 7 to 11, 222 from 7 to 11 on Tuesdays, and then on 70 centimeters every Wednesday. And then, of course, our MAD, we share the state with Midwest and North Texas. I've got a couple serious slides coming up, but first I just want to ask if there's any old business to be reviewed. Any new business? All right. Anybody have any other topic to be discussed? I'm going to show the slide that we have shown for years, but then I want to take you into this a little bit deeper. There's been some, I guess you'd say, discoveries by me that this is not really showing a truly accurate picture, but it's the same slide that we've shown for years. So I repeat it over here. Well, let me back up. Let's go over it one more time. The Zoom hosting, 160. Some of these numbers might have gone up, but 160 a year. Website Bluehost, 86 a year. Liability insurance, 200 a year. Post office box, 146. 501c3 nonprofit filing with Texas, 25. Then we have this line that says the total is 617 divided by $20 dues per head means we need 31 members minimum. Then this line is hanging off here that says this does not include the meeting room space and the ARRL Spectrum Defense Fund donations, which we regularly give. So, repeating that line, the total 617 divided by 20 per head is greater than 31 members minimum, does not include the Defense Fund donation. ARRL SDF's donation is approximately 300. So our total operating expenses are over $900 per year. This takes 45 supporting club members to equal our operating expense just to stay flush. The reality is, and I got these numbers from our treasurer, our account has averaged a $500 drop every year in the past 5 years. That's a short or a drift of $2,500. The math seems to indicate that we have 20 people in the club that are providing the support.
Jim, in this day and age,
that's the math. 900 minus 500 is 400.
in this day and age of email and computers, why is a PO box still required?
I think it's for the 501c3. Well, it's also so that it's not tied to a person. But
So
we should have Wes
this is
answer that.
this is Dave, KG5EIU. Had a lot of participation with the DARC, the Dallas Amateur Radio Club. We killed our PO box because it was just so expensive. And we got a guy that just used his address, right? So that's what we did because it's ridiculous the money that they charge for that PO box, and then someone's got to go check it anyway. So why not just have that guy that's going to check it? Why not just use his address?
Yeah, Wes, WA5TKU, did not want to use his address, and I think we kept it with the PO box just for 501c3, all our legal responsibilities. That's the only reason we kept it. I think some people do pay with a check, and that would be a good place for that to go. But Bob may remember more about why we did it, but I think it had something to do with the 501c3 filing.
That's right. That's what we were doing there. And also the other very important thing is it doesn't tie everything to one person. We work pretty hard to get everything away from one person so that if something happens to a fella that's doing all this work that's important to the club, then we're not out to lunch or having to try to figure out how to move things around. So that's a very important aspect to it as well.
Yeah, that definitely is an issue. The Dallas Amateur Radio Club, we went paperless. So we're over on Google nonprofit, right? Website, everything over there, and then everything's tied back to that. And then the only thing that ties to somebody or a call sign is the club call sign. So at some point you need a guy or someone, a call sign that's live for all that stuff, and that's what we use. So, but that would be the only thing that, God forbid, if something was to happen to that individual, that we'd have to go work on. Just throwing that out there if that helps at all. Happy to talk to anybody about it, how we do it, but that's what we do over at the Dallas Amateur Radio Club.
Set up a general email address, for example, email@ntms.org, and any club officer can check that email.
Yeah, we have that.
We have that.
Okay.
I appreciate the conversation. We might want to have just small group that would take this on. But I would think we would need Wes in there, as a central figure. There's a few central figures actually that know the legacy and whys and the design of the original whatevers. And I'm going to go on and talk a little bit more about that, but it is possible that there could be some modernization or reduction in some areas while still maintaining the basic principles that we've got to stick with. So let me go on here.
Let me mention before you go a couple of things more. One option here is to raise money another way, which turns around to have microwave update here, because that's how we've had infusions of money. And it comes down to people locally having to do a lot of work and getting paid for it in the form of having the club have a boost. If we didn't do that in the past, we wouldn't have had the money that we've had to spend. And so then the other option is to do some other club project to increase the income. Like, you're working your tail off on these beacons. Maybe we put together a project that's a beacon system that other people around the world can buy from NTMS, and NTMS makes money off of that for activities. And we have to be careful about the 501c aspects of things, but that's a possibility. Then the other possibility is raise the dues, either cut the cost or raise the dues and balance things out. But you can't forget that there is an infusion of cash occasionally from other sources.
Thank you.
The Irving Club is notorious for giving out grants and things. Usually every spring they do a grant request or proposal. Could reach out to Ken there, N2VIP. You guys put up all these beacons and, it's really impressive. Somebody has to pay for that somewhere. Someone's buying that stuff. So, maybe there'd be some grant money from the Irving Club. They're kind of rolling in a dough, as they say, just because of their situation over there. But they give out those grants, and you just got to do a little paperwork, take some pictures, and as long as it's for the community, they usually are very generous.
And that's an important aspect especially if you're a 501c, because you can't let your treasury grow too much. And so people that have that situation do give out grants.
That's exactly their situation, and that club is, they got like a bingo hall or something. I don't quite understand it there from that standpoint, but like I said, they're very generous. I'll talk to Ken the next time I see him. So,
Are you a member?
I am a member. Yeah, I'm a member of the Irving Club, and
Okay.
obviously I'm a board member of the Dallas Club.
Hey, keep talking because I'll be calling you.
Okay. Happy to help any way I can. You guys, I'm learning a lot here. So this whole microwave thing's new for me, but like I said, happy to help any way I can. And I encourage people to join NTMS. Your fees are reasonable. They're $20. The Dallas Amateur Radio Club is $32, and you get yourself in situations where your expenses exceed your ins and outs don't match up, and that's when things go wrong. So anyway, happy to help.
Thank you.
Mhm.
Anything more, Bob?
No, that's all for me.
So obviously, I mean, we've seen this in about 3 different ways, but like all things, there's a finite amount of time we can operate at the current drift down before activities of the club will be affected. And these are core items. I mean, there might be a way to improve slightly, but in my opinion, we should be doing more than this. Hopefully we can get in a position where we're given the grants. I want to talk about the website. Not sure who knows this level of information, but the number of unique visitors is about 1,600 to 1,900 per month. I'm going to show you the actual data. In fact, I went too far. Okay. And then the number of hits can reach 20,000 per month. So if I navigate to the website and then I click 5 times, the first time I show up in a new month, I'm a unique visitor and I've produced 5 hits. And our website also tracks what I download and how much bandwidth it required. I'm going to show you this. The referrals are from Google as the number 1 referrer and other search engines. Presentations from NTMS meetings being downloaded daily. So this is July, but I'll just stop here briefly and then take you right to the actual reporting engine of our website. Right here you can see in July, there were 1,725 unique visitors. Several of them came back for a second visit. There are 5,000 pages, almost 6,000. 13,000 hits, which breaks down to 4.5 hits per visit. And the bandwidth required is this number over to the right. So bear with me here while I locate this in my 55 open windows. Thought I was kidding, didn't you? Hell, shoot. Maybe I should just go right to it. So, yeah, bear with me. This is the panel I was looking for. So I'll have to use my presentation as a guide. So the first is to look at the downloads. Look at the navigation, take navigation downloads full list. Navigation downloads full list. Now take a look at this. Greg, do you see that the number one downloaded PDF in July was Arduino controlled ADF 4351. Next was a 2304 EME primer. And then the May Tropo opening. Then a WaveLab, then a AA5C, low cost 10 meg reference. Al's Central State document, so on and so forth. Now, if you change this to August, you'll see the update of what's happening right now. Again, Arduino controlled ADF 4351 is getting a lot of hits, and the WaveLab. The microwave update history.
What hosting plan do you guys have with the Bluehost there?
I don't know. One that costs $200. How do they find us? Refers, origin, referring search engine. Here's the search engines. This is August. Let's roll it back to July. Change much. You can scan down that list and see. And then here's the sites that have links pointing to us. So bobatkins.com, HB9AFO, some that I recognize, W1 gigahertz, radio astronomy, ARRL.org, newsvhf.com. IVJB.com. So those have links to us. Where are the users located? Look under who, locales, and full list. This is July. By and large, the big number is in the United States, China, Russia, Japan, Great Britain, Canada. What time of day and week? Go to when and days of week. This also has the hour on it. So you can see it's pretty static. And if there's anything that I can see here is that there's maybe a little more in the afternoon hours as far as the hits go. So there's that to illustrate the kind of activity that's going on with the website. It's not just sitting out there for the one or two times I need it a month. It's getting pounded, would be the word I would call it. So as we approach the end of the year, please pay your dues and take part in supporting NTMS. You may pay dues using the PayPal link on the website or send a check and money order to Wes. So I clipped this off the page. First, on the left-hand side, you go to membership in order to get what I'm showing on the right-hand side. And there is a PayPal link there. For new members just joining, we have a form to fill out. And then I also, while I'm on this slide, want to point you to a new link in the navigation bar on the left. It's called Conference Presentations. In here, you will find members' presentations that they've given as they go to different conferences. It makes it a quicker, easier way to find those data instead of going to the at the meetings link, which is just below it. For donations, which we encourage, here's the post office box. Just send your check or money order. You can also make a donation through PayPal. And this original link is found at the top header of our page. It's on every time you look at the homepage. Now, this is my serious slide. And I'll start off and just submit to you, is accurate and reliable information ever really free? We might think it is, but remember, there's a lot out there. Is it accurate and reliable? I would submit to you that no, some price was paid to obtain, maintain, and archive the information. Somebody somewhere had a cost. At NTMS, our information is ad-free, but it came at a cost. Think about the combined experience of IEEE members in our group, the RF engineers still working and retired, and the operational skills gained over decades of time. That knowledge and skill does not come in 2 months or 6 months. It comes in years and years and college degrees and street smarts where there's no college degree, and falling down many times and blowing up stuff, letting the smoke out. That costs. Next bullet point, the next generation of microwave operators are among us today. Some of you are on this call. For our mission to succeed as a society will depend on them and the persistence of NTMS resources. We can't let the tree dry up and die, or somebody's going to be starting all over someday. So expect that we will be socializing the need for member support through email and other messaging. And I think we've stirred up this group enough that, we've got some takeaways to explore some other avenues. And so I'm happy that it's got that response from this group. And I know that the great majority of you are serious, and you contribute every way you can. And I appreciate the experiences that you share and the information that you constantly make available as you make discoveries. You share your struggles, your burdens with whatever it is you're trying to accomplish. And that all matters. It does continue to lay down new asphalt, if you will, or information that helps us understand where you're at, where you need help, what we can do to help you or somebody we know that can help you. Those are all the information flows that are webbed together, and they're traceable back to those of you that are willing to contribute support. Now we need some money, and that would be greatly appreciated if we can curb this drift and get us back in a place where we're at least flush or moving into the black. That's all I have. Anyone want to talk any more about that?
Just out of curiosity, what are you guys short right now? Do you have a number?
We're not short. We're just drifting, and so if nobody did anything other than what they're doing today, 12 months from now, we would say we probably have $500 left.
Okay. Collision alarm. In a minute. I got it.
Yeah, it's not diving. It's not in a flat spin, but it's gliding downwards.
Well, it also prevents you from taking on another beacon or spending money on some project that you might otherwise do that would help the community.
I have a question.
Let me make one other comment. I think on the webpage, we should add a line item at the bottom that says, if you like what we're doing, please hit the donate button above and make a contribution. And I think that would generate some more donations. I don't think that donate button shows up, and we need to get people to do it somehow, or motivate other people that are doing all this downloading to do it.
Okay, Bob, I've written that down.
I have a question.
Hey, Darren.
With the PayPal deal, is there a way to set up like a subscription? Because I'd be willing to contribute on a monthly basis, over time to help out where, that way I don't forget to pay my dues or anything like that.
Writing it down, Aaron, because I don't have the answer at the moment.
Yeah, because like I pay my my video camera subscription fee or whatever on a monthly basis to Arlo, and so if I could do the same to the club, I could donate on a regular basis.
Yeah, you could start a thing.
Yeah, this is Al, W5LUA. It's like Jim says, we're on the downward trend, but we're fortunate to be able to benefit from the estate of Bob Gormley several years ago.
Right.
All the equipment was donated to the NTMS, and I took control of selling it, and we had at least $4,000 worth of income from that. So that's helping us through this time, but that money really needs to go to beacons, and we've actually voted to do that several years ago, and we haven't quite done that yet. But Jim has put a lot of money into the devices for the beacons, and once we get it finalized, I want to put in a motion that he be reimbursed, and anybody else that made a monetary contribution to it. And so just keep that in mind. That's because we can easily spend $4,000 on beacons. I mean, the LOs cost what, $700 or $800, and those multipliers cost the 47 gig multipliers cost 400 and something, I think.
Yep.
So there's we need the money for that. But like Jim says, we're not going in the right direction. So at some point, it's not going to be good.
Thank you, Al. Takes 8 years to draw 4,000 to zero at a rate of 500 a year. 8 years. And then Bob died, probably about 8 years ago, wasn't it?
I don't remember. It was pre-COVID, right? Or was it? Yeah.
Yeah. It was definitely pre-COVID.
Yeah. I was thinking it was 17 or so, 2017.
Mm-hmm. Okay, that's nearly 10 years. Well, it's 8 years.
One other thing that's going on here Jim is working very hard in a lot of different areas because he loves this what he's doing and he enjoys giving a contribution, I believe, which we're very fortunate to have him doing this. And one thing he's doing that you may not realize is the recordings. He's making these recordings of these meetings and then he's posting those. And so you can download them and look at them. And I'm not sure how you've gone about doing that, Jim, but if it's coming back out through YouTube, then usually there's some kind of a revenue stream there potentially, unless you've got it done in a way that that doesn't happen. But I know that Sarah, the radio astronomy group, is getting some money back from YouTube. And that's another possible income source. Now, the issue here, though, is if Jim gets burned out or stops doing this, I told him not to do it in the beginning because I know that it is a tremendous amount of work to record it, make edits to it, and get it posted and deal with issues that come up to keep the things alive. But on the other hand, the papers and things from meetings and the YouTube videos are like it's like a history or a background that gives this organization a great deal of credit and position out there in the world. And it will continue to grow as every month, that new presentations are put on or new things are written up. That inventory of material will continue to grow. So it's a very nice thing and should encourage us all to want to make more presentations just to be a part of that. So I hope that if we can do the YouTube thing or if we keep doing it, if individuals wanted to make a presentation, one of the things that the Sarah group has done is some people have made a video explaining something about what they're doing. So you would make a video about some microwave topic and then contribute that to the NTMS library. And they would show up on YouTube and then potentially that would generate revenue also and help bring new people along or help new people learn how to do microwave. So that's just another thought that I have.
Hey, Bob, I made some notes.
Okay.
Okay, it's getting to be 3:30 here in Central Time. Do we have a motion to adjourn?
I motion that we adjourn.
Hey, Bob. That's all I think we need. Al gave us a second anyway there, so thank you. All right. Thank you for joining in today. And
You got
for
you got a
you,
little
if
bit
you're
of, you got a little bit of time to talk about your brain scatter thing. I'd like to hear just a little bit about that. If there's time enough to do that or not, let me know. If not, I'll wait till next time.
Quick question for you, Jim.
yes, sir.
If I was to send my membership in rather than a check, what do I use for PayPal for an address?
If you just hit the donate button on the web page, I think it links you into PayPal in a way that it'll flow. That's what you're trying to find out, right?
Yeah, it didn't
Yeah.
seem to link me. It tells me to send a check to Sanger, Texas.
Okay.
Hang on. I'm in my crazy world here.
While he's looking, I just want to comment, we appreciate all the remote people that have logged in here today to participate too. And we're happy to see you and enjoy having you join us.
If we can override this.
Okay, so I was looking at the button at the very top of the page, and that's the one that sent me to the
Yes. And that's actually what I told you to do. But looks like
Okay.
this is going to get stuck at 20. So if 20 is the amount you want to send in, then you could use this.
Okay, well, that's fine. Yeah, I'll look for it on the left-hand side there on the full page.
Good call out. And by the way, you can hit that button about 10 times and give us 200. Probably blow Wes's mind.
Yeah, I'm sure. All right, thanks, Jim.
Yes, sir. Yeah, and I owe you, Barry, a follow up on something I'm going to get to tomorrow afternoon.
All right, sounds good. Yeah, well, there's no hurry, Jim. I know you got a lot on your plate.
Okay, so I had this in the first slide, and it just illustrates a problem. And those among us that have played with rain scatter know what this problem is. And what we see here is my location up here in the upper right, my partner's location down here to the lower left, and we see the red circles, and we see a couple of white with black border circles. And so what I've done is I've clicked on my partner, which is this thing that says DX, this bubble that says DX. I got distracted, Bob, because I saw this donate button down here. Maybe we could put the not donuts, donate on every video and just make it persist. Got me going now. So anyway, this white dot here is going to be the storm that's up here in this table. It's not a big storm, but it has good reflectivity, or it wouldn't have been turned white. And there's a help page. I really think we need to do a presentation on this because Andy Flowers, who's the creator here, has a very elaborate set of help instructions that go through how to use the basic functions and then the more advanced functions. But what I'll just tell you is very obvious here is the direct bearing is on 218 and 38. These are true headings, but 218 and 38 would be the reciprocal. The scatter as is on 221 for me, so it's a little farther to the west than the direct line, which is the heavier black line. But the elevation is considerable here, at least when you've got a 35-pound rover platform on a shaky tripod. So I've got to point up 4.2 degrees, and my partner has to point up 5.6. Well, that makes sense because the cell's closer to him than it is to me. But this implies to me that if I had a horizon that was clear, I'd see that thing out there 4 degrees high. So the problem here is the attenuation through the existing rain. So that's going to affect my partner on transmit to the reflection point. I better not use a word like reflection. Let's just say to the cell. And it's going to affect his receivability when I'm transmitting from the cell to him.
So did you always have to transmit through the cell, or can you transmit, could you both be like on the west side of that storm, let's say?
Well, yeah, if we knew how to beam ourselves over to that other location. No, I'm sorry, don't mean to be a smartass, but this weather pattern persisted for like a week.
Right.
Caused the deadly flooding down in the hill country. And then it caused floods in this area, flash floods. And the problem was every day we would go out and try, but it was not going to work as long as my partner is being affected by this tremendous amount of attenuation here. Now, if my partner had been, say, up here up here to the 9 o'clock position, this might have been better with the reflection point at 90 degrees from us. It's there's a lot of experts here that can probably talk to this better than me, but it's always better if it's in a direct line. Some of our long distance rain scatter contacts have occurred where the storm was between us, but each partner was not also occluded by a rainstorm sitting on top of them.
Right. So that would be the ideal condition would be to both be at some sort of an angle where you were not included by a heavy rainstorm or something. Is that a safe assumption?
It's best to be in line. It's best to be in line.
Okay,
this looks pretty good here if you just take away all the rain that was, in this darker green. However, this storm is very low compared to what we've had work for us before.
Well, 15,000 feet is what's on the screen, right? So,
yeah, I'd have to go to his help page, but I believe the maximum reflectivity area aloft in the storm is 15,000 feet high.
Okay.
Some of our best DX, like I said, we've got the patriarchs of rain scatter accomplishments here on this call. I'm aware of one that we made a few years ago. There was a group of us that were lucky and got a storm in Oklahoma City it was east of Oklahoma City, but it was over 70,000 feet high.
Wow.
And so that wasn't like 10 degrees above the horizon for us. It was just barely above the horizon. But what it did was it supported ultra long contacts up into the northeast corner of Kansas. And I'm thinking it was not quite directly in line if you were to draw a straight line between those of us that worked Greg up there in Kansas, but it was close. And it was beaming down 100 degrees where I was, and it was clear and no storms where Greg was. So, we see this pattern set up. We see attempts being made, but usually these contacts don't work. And it's because of the heavy attenuation of the moisture in the air to contend with. But among the material of making presentations, this one would be a good one to explore a little more. And it'd be good if we could get some successful rain scatter contacts under our belt too, with some forensics or documented evidence of how those were accomplished and where the limits of it were. I know I'm way, as you can see on this map, I'm way down here below Fort Worth. Al and the hub of activities way over here, 100, 80 miles from me by straight line. And there came a day when a storm started brewing to the east near Greenville, or it was actually just west of Greenville, but it was growing very fast, and yet it wasn't moving. The cell was growing in height, but the storm was not, going 70 or 80 miles an hour like they do at times. It was moving 20 miles an hour, if that. So it was just pouring and dropping hail and everything else. And I had time to rally and drive down right about to Hillsboro here, and then get up here at a high spot in the country where I knew I had good horizon, and we worked the heck out of that storm. We could hear the beacon. I could hear the beacon all the way in Denton, just booming in there on rain scatter with spread signal. But I was able to work Scott and Keith, I believe. And for Scott, that was a new grid in EM11. So that doesn't happen every month. It's just luck of the draw. And it was a weekend day, and I wasn't up in Irving working. And so sometimes you get lucky. It's like going fishing.
Yep. Hey, Jim.
Yes.
On that particular contact that day, I think we started out pointing towards the storm there in Greenville or wherever it was, the east, southeast of me. But after we worked, I started spinning the dish around, and it didn't matter where I was pointing the dish. You know, I could copy you looking northwest, west, north.
Oh.
The beacon's the same way. So, you know, there was a lot of moisture in there that day too.
Yeah. Yeah, it must have been, because you can understand the beacon bouncing or whatever it does. It reflect off of the raindrops in the big storm. But for those referrals to come back and then be copyable when you're pointed away from the storm, that would have to take more moisture, I think. I'm sounding like an expert here, but I don't know.
Blowing me away.
Well, any more, David?
No, thank you for that. You know, I'm really new to all this and trying to soak it all in and make you know, I've yet to make a contact. So I hopefully will get my station ready, that it will actually be fully assembled and operational. Unfortunately, not for next weekend, or I'd play with you guys, but maybe for the next one. So we're trying hard. Yeah.
Yeah, good. A few about 5 or 6 weeks before we come back around on it again. Of course, then we have our monthly first of the month, first Saturday of the month.
That's I'm open to make that one the mud day. MAD, microwave activity day. Yeah.
Very good. All right. What's next, guys? I think there's going to be some 24 gigahertz attempts this afternoon. Is that my understanding right?
Yeah, I'm gonna set my stuff up and try to work Paul and see how things work out.
Good.